Hi, welcome to our 4-bit processor by Pat, Thomas, and Joshua. We will demonstrate our working unit.
Let's put a space at the end of the input.
The unit is made of several different parts, and the first part is the binary counter.
So the binary counter is very simple. It will simply increment from 0 to 255. In this design, we only use values up to 128, but it is capable of going up to 125. It takes in input from the system clock, chip enable, which is always high, the clear, and it will output 8 digits to the PROM. The PROM is what holds the instructions. This is our PROM. So it will take in 8 inputs from the counter, and it will call a function in the instruction decoder and send data to the mux. So let me show you how this works. Alright, so here's the Verilog for this. So what it does, you can just read it. It just reads in values, and then it will display them. So you can see display hello BG, and it works in the same exact way for the numbers. So it's that simple, and that is the PROM. So the PROM will feed in instructions to the instruction decoder.
And this decoder will take from the PROM one of 10 different commands. They range from moving the value that was in the PROM to the register, and it can choose between the first or second register. The decoder can also write enable, LCD display, the ALU, and the mux as well. It acts as a selector between the different commands in our ALU. It can select between add, subtract, and, or XOR. And then it can also move whatever value is stored in the accumulator back into the mux, which then pushes to our register files. The decoder sits above our mux, which is simply 4 2-to-1 muxes that select data coming from the 128x8 PROM or the ALU. And these values feed into one of 2 registers for the values to be stored.
Alright, so we have our arithmetic logic unit with accumulator. It adds ORs and XORs, and it can send out its bits off to storage. If we go to the schematic, we'll see that it takes a 3-bit address. First, up on the top, it takes an adder subtract select line, and then close to the bottom takes S select 1 and select 0. This 2-bit address will select between the adder, our OR gates, AND gates, and XOR gates. It also takes in 2 4-bit numbers off of the register file, and it outputs its result from the accumulator into the data mux to be sent to the register file. If we go inside of it, we can see how it works. On the left hand side, we have a very large demux. This demux takes in the 2-bit address S1, S0, and S1. This selects either the set of gates or the adder, which is up a little higher on the schematic. And on the adder, we have added some XOR gates onto the B inputs. This allows us to subtract along with a carry in. This subtracts on a high input. Now, from our results, we have a mux. The mux takes the same address as the demux, so it automatically sends the result of the operation to our accumulator. And the accumulator then just keeps it and sends it out to the data mux, and there it can be stored to add again or be sent to display. The register file, it says just 2 4-bit registers, register 1, register 0. We have them hooked up with the write enable, and so we can pick where our data is going to send to the display or send down to the ALU.
So that register file, it sends output to our ASCII display. So our LCD controller, very simple. We'll take in inputs from the register and a chip enable to make sure it reads to write, and it will output those digits to the board. So with all that, you can see that it works like a charm.
Let's put a space at the end of the input.
And that's our circuit. Thank you for your time.